Hello. Can everybody hear me? Can you hear the fan? There's if I shut up, I think the software cuts it out, but I don't know if you can hear it while I'm talking. Let me know if you can. My mouse there it is. So how many people do we have? That message on the screen. That one. You're all awfully quiet. So this is the gimbal. This is what we're gonna be playing around with and modifying today. Well, we're designing the modifications for it today. This is a really cool project. Let me turn this off because that fan's annoying me. So this is the whole gimbal, and as you can see, it's quite substantial. It holds a DSLR or mirrorless camera. Let me grab one. So you mount your camera onto the top of it like this, and then it spins it around and tilts it up and down and moves it around, and you can pre-program all the moves using the same G-code you use for 3D printers. One thing I am going to have to be really careful of, there's pegs that hold these two arm assemblies together, and I don't want to push them all the way in because I'm going to be dismantling this. I want to be able to get those out, and I accidentally pushed one in all the way once, and it took me 45 minutes to get it back out again. But this was my first test print of this, and I got another test piece here. This is one of the parts we're going to be redesigning today. But grabbing this box, shift you out of the way a little bit. These are all the parts that I've been reprinting. This one was printed in regular PLA, and this was all printed in the Airy One PLA Plus. We've got all the individual little arms, and the motor mounts with the motors on them ready to go, and these are just the standard NEMA 17 motors, just like in most 3D printers. I've got the arms and the side bits and all the bearing holders, and one other change that I'm making from the printed design. There's two small little cogs, and what I've done is I've gone and bought metal ones, because from the comments I was reading on the project, these are the bits that tend to wear out the quickest. So I thought, well, if I'll just replace these, and if hopefully the big cogs won't wear out very quickly. So, but we'll see. Right, now I gotta get all this stuff out of the way again. So who's tuning in? Who's watching? Because the stream says there's 10 people watching right now, but nobody's saying anything. So who's here? Somebody say something. So another part we're going to be redesigning today is this whole arm across the back, because I don't know what tripod the guy who designed this has, but this doesn't fit like any standard Manfrotto photo or video tripod plate, and it doesn't fit Arca Swiss plates either. So what I've done, if I can find where I put it, is I went out and I bought a proper Arca Swiss mounting plate. The problem with this is that there's no way to mount it. There's no holes underneath. So I did a couple of little blocks to test. Whoops! I did a couple of little blocks to test it at the same thickness and height as this bar, and added a couple of mounting holes. And as you can see, they fit. I finally got them to fit perfectly. So what we're going to do is we're going to recreate this bracket in Fusion 360. I'm going to keep these two holes there for an inductive sensor, which is this thing, which will mount on here. I don't know if I'm going to use this yet or not, but I want to have the option. So this mounts on here, and when it gets down to the level, it detects a screw in there and it knows it's at 0. There's another one that goes in here and detects a screw down at the bottom there, so it knows when it's positioned at 0. This one I'll probably keep. This is one of the reasons why we're designing this, because I also have a bunch of end stop switches. So I might actually, or what I want to try and do today, is find a way to mount an actual end stop on here so that when it spins around it just triggers itself. So that's the plan. So the whole thing is controlled by an Arduino, which is in here with the CNC shield on top. And if I can open this, oh, people are talking. Hi everybody. So we've got a couple of TMC 2208 stepper drivers in here so that this is really quiet. I did try it with wherever they are. Are they in there? No. Oh, they're in here holding up my battery. So I did try it with some A4988s, and it was super noisy. So I've got a few TMC 2208, so I put a couple of those in there to quieten it down, and it worked really well. So I'm going to stick with those. So let's see. Hi, Baddish Crafts, Seppo, Barry, Food. Oh, you're just in time because I'm starving. And I am going to say this wrong, but Imki. Hello. Welcome. And no problem. I mean, I have to redesign this anyway. And I don't know. It's always fun to have people laugh at my ineptitude. So I thought, why not live stream it? Unplug you because all my wires are getting tangled. So this is a USB cable just going to my desktop, so I can control this and sort of quickly show you how it all works. And I've got a 12 volt power here. So the 12 volt powers these motors and the fan. So how loud is that fan? Can you guys hear that? Or is the software cancelling it out properly? So basically, if I put this in the middle here and move these out of the way, if I send it some G code, you can see the kinds of things that we can do with this, or a couple of the things we can do with this. One of them is for shooting panoramic photos. So I mean, there's a couple of ways you can shoot panoramic photos. You can just get a big wide panoramic lens and just shoot a really wide angle lens. But a common way to do it is with a process called stitching, where you take a whole bunch of images, stitch them together in software. Thank you, Baddish Crafts. Stitch them together in software, and then you end up with a much wider field of view than you would get with just the one picture of the lens. So I wrote, this is exaggerated, I wouldn't move the camera this much shooting a real one, but you can see when I start it, it moves over to the left and this arm tilts up. And it shoots a photo, it moves, shoots another photo, moves, shoots another photo. And then it'll do, like the way I've set this one up right now, it'll shoot 5 photos. And then it'll go back to the start and tilt this down. So you can see now it's moving it back and tilting the arm. And then it'll shoot another series of 5 photos. So it'll take one, move. And what will happen eventually is that this will be controlled by one of these, a little ESP32. And then this will talk to my phone. So I'll write a little app for my phone so that I can send commands to this, and then this will send commands to this, and that'll move all the motors, and it'll actually fire the camera as well, because the little ESP32 will be connected to the camera. So each time this stops, it will actually tell the camera to fire. But this is why I wanted to replace this mount as well, because when it's at an angle like this, like I don't even know if I've got a tripod plate handy. Oh yeah, I do. It's like when this levels out. So if I pull this out, this one actually kind of sort of fits. I mean, it's really loose. but it kind of fits. But you can see when I push it in all the way, and then that's supposed to be locked, but it still moves side to side, and it's still able to be pushed. So if you've got a heavy camera on here, it can still potentially fall out when it does that. Where'd my plate go? So yeah, so that's why I want to redesign these. But I think that's a sort of overview of what we're doing. I'll turn this off now. Oh no, before I do, this is a little file that I made. So you can basically program this to do any move you want. So if you're actually just filming a video sequence and you've got known points that you want the camera to hit, you can just say, okay, start here and then move over here over however many seconds, and then move over here over move over here over however many seconds, and you can tell it to pause and do other stuff, but it gives you a lot of control over what you can do with the camera. And if you're trying to time up camera movements with other things that are going on, like perhaps you're controlling it with like the ESP32 or something, and I don't know, you've got explosions set to go off at certain times or whatever, and you need to, you know, repeat the whole sequence 10 or 15 times, you can basically do that with something like this, just like you can tell a 3D printer to print the same thing 20 times. So that's basically what this is for. Right, we'll unplug that, we'll get these motors unplugged. So we've just got this, and we'll get all that lot out of the way. So the first thing we're going to do is, you would think it was the hardest, which is this gear, but this is actually the simplest, because Autodesk actually includes a script with Fusion 360 to let you generate gears. So that's what we're going to be starting with. So let me figure out how to switch this over to the desktop. And there we go, we're in Fusion 360. And my chat is... Oh, actually, no, I've got my chat up on the TV in front of me, so we're good. I can still see everybody. Enjoy my coffee. So, in Fusion 360, there are some sample scripts that come with it, because it does have a pretty advanced scripting language that lets you write things in Python or C++ or whatever you want, really. Well, not whatever you want, Python or C++, but you can make them do whatever you want. And if we hit Shift and S, you can see this scripts and add-ins list comes up, and these are the ones that come supplied with it. I haven't installed any, but down at the bottom you've got this spur gear, and there's two versions. There's this one in Python and this one in C++. And it doesn't matter which one you run, they both do the same thing, but Autodesk supply these as examples so that programmers can write their own scripts for Fusion 360. And if we run this, we get a whole bunch of different options. And here's our spur gear. And I've got the settings up on my other screen, or on my other computer. Now I've got to find where I saved it. Drive D video, that one. There we are. So it's a 20-degree pressure angle. That's pretty standard because this is a module 1 gear. So we're going to enter module 1, and 20 degrees is pretty common for that. On this big gear, let me do that. There we go. On this big gear here, there are 160 teeth. So we're going to enter 160 in here. No backlash. The radius, the root fillet radius, is this bit here. And I did some tests before, and I know this is 0.5 millimeters. Whoops. This box is weird. There's a bug in this script, I think, because sometimes when you go to type stuff in, it doesn't... There we go. It's weird. Sometimes when you go to type stuff in that box, it doesn't always acknowledge it right. Gear thickness. So here we go. I have my calipers, and I hope you can read this on the screen, but we'll like ride it around sort of 8 millimeters there. So we'll tap in 8mm, and in the end of here that you can't actually see, actually you can see it in this one. In the end of here, there's a hole. There doesn't need to be a hole, but there is one, and it's 5mm. 5mm. So you can see it says the pitch diameter is 160mm, which is basically the diameter about halfway from the top of the tooth to the bottom of the tooth, all the way around. And now we just have to sit and wait for it to calculate its thing. And I don't know how long this is going to take, because this is a moderately slow laptop. But this is the one I use for live streaming, so this is where I installed it. I'm going to bring my live chat up here. If you have any questions... Yes, oh, crap. Right. The video is on top of the... Right, we'll make that again. So we'll go Shift and S. Just to walk through this again. No, not create. Run. There you go. So there are all the settings. You can see the dialog box now. Oh, God. Right. So what was it? Module 1, 160 teeth. Root fillet radius 0.5mm. Gear thickness 8mm. And hole diameter 5mm. I'm going to bring this in. We're going to click OK. And it will now generate our gear for us. And it'll take a minute. Like I said, this is a... It's not a very old laptop, but it's not my most powerful computer in the house. But there we go. So there is our gear, and it's literally just the gear. So we've got a hole in the center. We've got 160 teeth. We need to now basically make this match the one that's part of the Gimbal project, because actually let me just go full camera. You can see here in the middle there's this whole spindle section, and this, if I can grab my other parts, so if I get that and that, so basically on one side this is a little sleeve, this holds a bearing, and then that goes in there and gets screwed in, and then this basically sits in there in that bearing, and that's what it spins on. So we need to have this come up, and it needs to have all these little bits at the right heights just to make sure it holds it in the right position. So what we're going to do is we're going to go download the original file and bring the STL into Fusion 360. Which is something you don't see a lot of people talking about, how to bring STL files into Fusion 360. But this is the gimbal. You might recognize it now. You've actually seen it in action a little bit. We're going to download this, and then we'll bring the files into Fusion 360. No, I want to totally minimize that and that. New folder, Gimbal. And then when you've got STLs like these that you want to bring into Fusion 360, it's really easy to bring them in. All you do is go up to Insert, Insert Mesh, and then you go find your STL, and it is literally that simple. So Desktop, Gimbal, Files, and the one we want is Spur Gear 160T. So it should be already... Oh, no, we don't want to do that. It's pretty much already in the right spot. You can see that it's actually conflicting with the one that's already down there, which is why we getting that flickering on the faces. So we'll just bring it in where it's at. You can see if we... So there's the spur gear that we made. There's the STL file. So the main things we got to do are to recreate this little nubbins sticking out and add these two holes. And on this side, is there? No, it's here. There's a, you can see that the heads for these screw holes are countersunk, so we'll deal with those as well with a chamfer. So what we want to do is we want to actually bring that up. We want to create a sketch. But what we'll do, it's awkward doing it this way. I mean, it works really, really well, because you basically get access to the whole original file. You can, you know, load it up and compare it with the one you're working on. So it's a great way to duplicate models in Fusion 360, but it's awkward because you've got to keep turning things on and off to make sure you're selecting the right thing. So we're going to create a new sketch, and we're going to select the front face of this gear, the one we created. And then we're going to hide the gear we created and show the one that we're copying. And inside here, I'm hitting C to make a circle. And we can see if we angle it exactly which ones all come up. So we're just going to make that one, that one, that one, that one. And we don't need an inside one, so we're not going to make that one. So we're going to make one. And we're back. The other two small holes on the side. So you mean these two? Whoops. These two, this one and this one. I'm not going to be adding those in. That's one of the things I want to take away. So that's one of the reasons I'm recreating it, because I want to add my own holes, and I still need to figure out exactly where they're going to be. But I wanted to show you, I mean, it's basically going to be the same process as creating this hole and this hole. I just don't know exactly where they need to be placed right yet. So I'm not going to be creating those, but the process is basically the same as creating this one and this one. But okay, now the stream appears to be back, so we'll go ahead, back on that sketch. I'm going to hit C to create a circle, click right in the center, and I'm going to drag one out to here, and I'm going to tap in 10 millimeters to lock it in. And I'm going to create another one here, which is 13.5 millimeters. I'm going to create another one here, which is 18 millimeters. I'm going to create another one out here, which is 22 millimeters. And those are our different rings that we need to extrude up for each of these bits that stick up. We're also, while we're there, we're going to double click on the sketch to bring that back up. And I'm going to create these holes here. And these holes are, I love how well aligned all this is, because this right here is basically the center. So I'm going to hit C again, click in the middle, and drag this out until I can see sort of roughly where it is, and it looks about 3.5 mil. So we'll type in 3.5 millimeters. And I'm not locking these dimensions. Good practice says that you should, but honestly, for what I'm doing here, again, I'm just hitting C, clicking in the middle, typing 3.5, and hitting enter. For what I'm doing here, it doesn't really matter, because I'm only really creating this for myself. But what we're going to do now is, the first thing, I'm going to finish this sketch. I'm going to click that one and that one, and we'll get these out of the way because they're easy. So I'm going to hide that and bring back our cog that we made. And I'm going to hit E to extrude them. And normally to cut a hole through, you just drag it. Like if you want to... no, I didn't want to do that. Stupid thing. Now I got to select these again. It's really easy to accidentally misclick stuff. And I like in a lot of other 3D software where if you click something and it messes up your selection and you hit undo, it brings you back to your previous selection. This doesn't. But, right, so we'll hit E to extrude. And normally, you know, if you pull out, it extends them. If you go the other way, it cuts into the body and makes a hole, but then it can potentially come out the other side as an extension. So what we're going to do is we're going to change distance to object, and then I'm going to select this face as the object, and then it'll just make sure your operation's on cut, hit OK, and now you can see it's cut those two holes all the way across, and the only thing left to do with these two holes now is to chamfer these. So I'm going to click one and then shift click on the other. And on the modify menu, we've got fillet and chamfer. And fillet's like a rounded over one. Actually, let me show you that quick. So fillet's like rounded over, which is really handy to sort of relieve sharp edges on models. And it's what happens in between each of these tooths. This curved bit here is a fillet. This is really frustrating. So I don't know how much you caught of that. For some reason, my laptop's just deciding today that it does not want to stay on the Wi-Fi. I have no idea why. Because my TV's staying on the Wi-Fi, my other computer's on the Wi-Fi, my phone's on the Wi-Fi. The laptop's the only thing that seems to have a problem with it. But yeah, so I'm going to go back a little bit. So yeah, so these are fillets. And normally it's like these are rounded over edges, so it's basically allows you to soften the edges of your objects so they're not sharp, and that's exactly what's happening down in these corners, which I think is what I was talking about when I got cut off. So this right here is a fillet along this edge. Without this fillet, this would just be a straight line, just like these. Actually, if I show you this corner, you can see if I fillet this, exactly what it's doing. So you can create like a rounded over edge. If I had another one here, so you can see there that it's, so we changed these to, let me just add them both again to the single thing so they both move together. So you can see there. So you can round over edges like this. It's very handy. We're not using it here on the teeth because we don't want to, because they're all the right shape and size. But we'll click that again. We'll click that again. And we're just going to go with a straight up fillet, which is directly below, or a straight up chamfer, which is directly below fillet. And here, I want to say it was 2mm. Where's, you're up here. So that should be right, and we can bring up the original model to check, and you can see there that it's exactly 2mm because this outer circle, that outer circle doesn't actually exist in the model itself. We've created that by adding the chamfer, so that outer circle matches up with that, and this is at 45 degrees because that's what M4 screws are, or M3 screws. So that matches up fine with that. Now we just need to deal with all this crap in the middle. And the easiest way I've found to do this on this model, and this is what I meant about it being really great to be able to bring the STL file in to compare and measure up, but it makes it a real pain because now I've got to hide both of them and show the sketch and figure out the best way to extrude these out and which ring is which piece. So I'm going to work from the tallest to the shortest pieces. So this ring here is the first one we're going to extrude. So I'm going to have my models off and the sketch on, and have that ring selected. And I'm going to bring the original body back up. And I'm going to need them both on. And I just messed up because I deselected the ring that I need to extrude up. So I'm going to have those on. And then I'm going to extrude, hit E, and pull this up. And the great thing is you can see exactly where it meets up, and it shows you the distance there. So we know this is 13mm. That's it. That's that one done. I'm going to hide those again. Select the next one out. Bring those back up. extrude this one up. And I think, yeah, so this one's 5.5 millimeters. And that's that one. Now we've got, whoops. Now we've got that one up. Then the next one is going to be this ring. So high dose. It's really, really easy to do this stuff. This is what I love about it. And what I'm going to do, I'm going to extrude this one up to the top of here. Like it wants us to, and that's 4.5 millimeters. But then I'm going to do this bottom bit slightly different because you can see that it's, oops, you can see that it's tapered. If I hide these, so you can see that this edge is tapered, and you can't easily sort of extrude at an angle like that. I mean, there are ways to do it. I'm not necessarily confident that I know how they work, but one method I have found for this is that I am going to select this, and we're going to go back to our friend the fillet, and we're going to go modify fillet. We'll turn our sketch on, because what we want to do is we want to fillet this out so that it matches that line at, come on, no, one, there we go, at 2 millimeters. And now you can, oh no, not fillet, wrong one, cancel. Chamfer, not fillet. I'm going to select that ring. We're going to go chamfer. And we're going to turn our sketch back on. And again, we're going to go 2 millimeters. Hit OK. And you can see that that 2 millimeter chamfer has, let me straighten that up. You can see that 2 millimeter chamfer matches the original model pretty much perfectly. So we've basically got all our sizes done. This ring here actually looks like it should possibly be a little bigger. So I'm going to go into my sketch. You can go into previous sketches. This is one of the great things about Fusion 360. You can go into one of these past settings, like that first extrude that we did, and change the settings of what you did, and it will update everything else. But what I'm going to do is I'm going to double click on my sketch, because I think this one, is it 14 millimeters? Let's have a see. No, it's, I mean, it looks like 14's too big, 13.5's too small, so we'll do 13.75. Make it match as good as we can. Right. Although that looks a little bit bigger than the original thing. I'm wondering if he's made it slightly undersized to make it easier to... Yeah, he has. He's done it 9.75 instead of 10 and 13.75 there instead of 14. He's done them slightly undersized just to make it easier for them to fit into the bearing. But we've basically now we've basically recreated it with the important features, which are the 2 mounting holes which screw into they screw into here. So it's these 2 mounting holes here. One's there. Oh, I gotta bring my camera back up for you to see that, or you can't see it. So we've basically, let me do it that way. So if I hide that, you can see if I try and match the orientation here. There you go. So you can see that we've basically recreated this with those 2 holes and this center bit. Oh, I've got this. Why am I holding that? So we basically recreated the cog with this hole and this center bit that sticks out and slots into the bearing. The limit switch screws, I'm not entirely sure of the actual angle. I actually need to find a protractor or something and figure this out, because the camera goes in this way, so it's facing that way, and then there's sort of a minimum angle that it goes to, and that's the angle that I want it to hit the limit switch at so that it stops. So I need to measure. I mean, it's pretty much when these are parallel to this, but the holes for this are on the wrong side and they're not quite far enough apart. Actually, we could measure this, cause if I figure if, oh yeah, okay, so we can actually use these holes as kind of a reference point, because if we line the left side of the limit switch up with the center of those holes, that's pretty much perfect, like distance wise, because that would put the camera pointing down at that angle, which is a little bit more than I'll ever need it to go. So if I figure out where those holes are and measure that far across, that is, let's see, so that's 16.2 millimeters, that board. We'll call it 16 because there's a little extra on the board. At different parts of the board, it's different distances. So we'll call that 16 millimeters. The holes themselves for mounting, it's going to have to be these two, because we can't use those two, because if we use those two, there's no way to actually get a plug into the socket, so it'll be those two. And those are, remember this, there'll be a test. Those are 19 millimeters apart, or is it 20? Yeah, so those are, let's see. Yeah, so those holes are 19 millimeters apart, and they are 3.5 mil diameter. I am going to have to write this down, or I will forget. I don't have a pen. I gotta. You know what? I'm just going to put these in the chat. Hole 9 millimeters apart, 3.5 millimeter diameter. There we go. My YouTube live chat is now my personal notepad. And the distance we need these from these holes are in the center of these holes, because if that lines up with that. So even though we don't know the exact angle, it doesn't matter, because these holes are parallel to the holes that are already there. And they are about 12.5 millimeters horizontally. Okay. Well, let's go back to Fusion and see if we can figure out an easy way to do this. So the original holes are here. And is there a way that we can rotate it so that, no. Okay, what we'll do, I'm going to make a new sketch. We could edit our original sketch, but I'm not going to. I'm going to make a new sketch on this surface. We'll give it a minute to think. Okay, and then we'll turn this on, and we're going to create. So we need to get this close enough that we see the grid line. There we go. And so the center is awkwardly placed. It'll be close enough. So the center is roughly, come on, there. We'll go 3.5 mil. See, these holes aren't 3.5. They're, are they 3? How small are these holes? They're 2.5 mil. They do have a very, very slight little chamfer, but I'm not seeing that on the real part. Maybe it's just because they're so small. But yeah, we're going to make we'll keep them at 2.5, because basically these are 2.5 so that you can screw an M3 screw into them and it'll bite right into it without having to need a nut, but you do have to be quite delicate with them. And we'll do the same here. We'll set one. Where's the center line? The center line is about there. God, it's awkward. So there's one. So we're 2 up from there. I'm sure there's an easy way to reference. It's about here. So there, we'll call it there. We'll see what happens. So 2.5 millimeters, that looks close enough. So basically, if I hide this, these are our 2 holes that are the 2 mounting holes that were already in the plate. And I'm going to make 2 more. And I'm going to make these 2.5 millimeters and another one 2.5 millimeters. And it really doesn't matter where these are right now. But what I'm going to do is I'm going to draw a line between the center of this and the center of this, because I want to move everything parallel to this. Because again, if we look at the plate, so these are the 2 holes, and this is going to be mounted sort of parallel to that, so that this edge lines up right with the center of those holes. And I probably want the corner of this board to match up with that second hole, because if we look at that here, if the corner of the board matches up there, then that should trigger as it sort of hits that wall perfectly. So if the corner's there, so I need to measure up from the corner as well. I need to measure across from the corner and up from the corner. So we've already got that. We're 12.5 mil across, and we are 3 mil up. So what I want to do is I want to create, there must be a way to create a rectangle. Can I do it from there? No, wait, what? Create a 3-point rectangle. If I do that, oh, there we go. So that was, hey, Christian. Oh yes, I've got some 3D printed other the heated screw inserts. They're really good, and I might redesign this in the future to take advantage of those. Yes, they are really good. I just haven't played with them yet. But we want to go what was it, 12.5 millimeters across, because we're only interested in the hole. So both of these holes will line up with this, and we want to make this one sit along this line. And if I hold D and click on that and that, no, why are you not doing it? There we go. And it was, what was it? I just measured it. Was it 3.5 mil? I think it was 3.5 millimeters. No, it was 3 millimeters. So if I, where did my distance thing go? There it is. So if I enter 3 millimeters, 3 millimeters. So that moves that hole across, parallel or perpendicular to this, and then it moves it up 3 millimeters. And then this one will also be along that line. Well, let me move you. Why won't you let me move you? Oh, because I've still got the distance tool on. So you're also going to be along that line, and you're going to be, what was it, 19 millimeters apart. So if we hit D again and click from there to there, I've done it again, haven't I? And hit 19. So now these 2 holes are parallel to the original 2 holes. They're 12.5 meters away to millimeters to account for the distance between the center of this and the center of this. And they're position 3mm up. So if I extrude these out, if I finish this sketch and I target, I'm going to have to select halves of circles here because it's cut down the middle. There we go. So if I select those now, bring up the spur gear, I can extrude those to object, select this wall, and now there are my new mounting holes cut out, which are across just far enough that this mounts in that exact position. And then I'm going to add a little fillet on this. Let me hide that again. Not a fillet, a chamfer. Is 1mm enough or too much? Yeah, we'll do 1mm. Modify chamfer. Actually, no, cancel. I'll just double click that one. Remove you, and we'll add a new group. That one. That one. 1mm. Okay. So there we go. So I am going to be securing these in with either super glue or thread locker for now. I mean, this is mostly still just a test. I mean, this one here was my original test. This was just printed in PLA. The new one I printed out is in PLA Plus, and I'm still not entirely sure if I'm going to stick with. Excuse me. I'm still not entirely sure if I'm going to stick with the limit switch or go for the induction. So I'll probably be redesigning and printing this a third time. Oh, thank you for the tips, Christian. Like I said, I'm definitely planning to use it. Let me see. Actually, I've got them right here. So I have a big bag here of 100 threaded inserts. I think it's 100. Doesn't look like 100, does it? It looks like hardly any, but there are 100 in there, so I'm told. I did actually count them when they arrived to double check. But right, let me bring that back. But that's essentially, we hide the sketches. That's essentially our gear done. If I grab this one and hit M to move it and shift it out of the way, you can see we've basically duplicated that pretty much exactly. We've got the same number of teeth. The gears are actually, if I undo that move, you can see here that the teeth match up just about perfectly there. But our holes are in the place we want for our limit switch, and I'm not entirely sure what those holes are actually there for, because they don't seem to attach to anything at all. Even in the videos that he provides on the Thingiverse post, there's nothing attached to them, and the same goes with these holes on the side here. There's nothing that's attached into those either. These two are for another induction sensor. Like this one, there's a mount that screws onto there, and then this attaches, and then a screw goes into here, and when it passes it, it triggers and it knows it's at 0. But I'm not putting this on, I'm going with the limit switch for now. Can we a close-up of the threaded inserts? Absolutely. I actually want to build a little 3D printed kind of drill press that I can mount. Where did I put it? Where are you? I saw you earlier. I know you're here somewhere. Where are you? Hold on. So I want to build like a little drill press because this should, does that fit? So this fits perfectly. This is my, let me zoom you in and refocus you. So here are the threaded inserts. Here's my TS100 soldering iron. This is the tip for it. These fit, this fits perfectly inside here and it doesn't stick out the other end. Are you going to focus on that bit? No, come on. Oh, you pain in the arse. There we go. So this fits perfectly in the end of there. So I want to build like some kind of drill press that makes sure to hold that vertically. But there's your close-up of them. And you can see they have little arrows running in two separate directions so that you can, when it goes in and it melts into place. No, it's fine, Christian. I appreciate all the feedback. It's all really, really good. But yeah, I want to build like a drill press so that I can basically make sure this comes down vertically into the holes. So that's one of my next projects. Now I got to get all these back in the bag. But no, I actually only got these a couple of days ago. I ordered them off AliExpress like a month and a half ago, and they finally just showed up. Because I did want to play with these specifically for this actually. So I'm possibly, for now, I really like this design. Like I said, there's things I want to change, which is what we're changing now. But I think ultimately I will probably end up designing my own gimbal from scratch, loosely based on this, but probably not using any of the original parts from this. I love the principles of how it works. Like it's got a bearing on there and a bearing underneath, which is how that manages to spin, just on those two bearings. And then there's motors mounted to the arm and not the base, so the motor sort of moves itself rather than the motor on the bottom trying to move all this, which is kind of a neat idea. And I like the way there's a screw mounted on here for the induction sensor to hit, so that it knows when it's at 0. Let's check the comments. Nothing new. So that is basically then like the whole model for, let me go back to here. That is basically then the whole model for this. And if I do decide that if I figure out what these holes are for, and I decide I want that, I've still got them in my sketch here. So I can just, if I want to, I can just, let me see, turn on the sketch. I can just add those to the selection, I think. Oh, the computer's just going slow. It's thinking. There we go. Nope. Yep. So, I'm stressing it out. Alright, I'm going to cancel this as soon as it will let me do something. Yeah, because it's trying to extrude nothing, like everything, into nothing. If I unselect that, then it goes back to how it was. Okay, so if I just go into that bit. Is it going to do it? There we go. So if I want to, I can always just add those holes back. Oh, I've selected the big bit again. This is a really frustrating thing about Fusion 360 is that it like literally moving the mouse 1 pixel can select something that you don't want it to select, like the whole large plane instead of the little ones, like it's done here. So I need to unselect the big plane. And then there we go. So if I want to, I can just come in and add those back, but I don't want to. I'm just going to go with these two because these are the two that I'm going to be using for mounting the limit switch. And to export this out now is dead easy. All you need to do is go on the file menu, Well, we'll save it first. I did actually make one of these already. So yes, you see it's already there. So I'm going to call this 160 tooth. Oops, tooth gear and stop. And then that'll save out eventually. There we go. All you do on the file menu is select 3D print, target that, and I'm going to set my refinement to high. And I'm going to uncheck. By default, center 3D print utility is checked. And basically what it'll do is it'll save it out to a temporary file. It'll load up whatever your print application is, and then bring that temporary file into it. But then you've no idea what the file's called or where it's saved. So I just undo that, hit OK. And it'll ask me where I want to save it. So I'm going to call this, where is it? Spurgear 160. We'll call this John Spurgear 160. John Spurgear 160. And then if I come into here and double click it and we load it up in Cura, it will probably come in at an odd angle. This is one thing I haven't figured out yet. There's a weird orientation thing. But it might... Oh no, we're good. We're fine. And that's it. It's that simple. We're in here now. What I am going to do... I'm not going to use these settings. I know I made these settings, but I'm not going to use these settings. I'm going to use the same settings that I used to... I'm going to use the same settings that I used to print this gear, the 128 tooth one, because I've tweaked them just slightly to speed it up a little bit. It's slow like my sort of normal speed print, but the layer height's 0.24 instead of 0.16. But let me actually, I will be right back. I'm going to go grab the USB stick out of the Snapmaker. Hold, please. Where's the mouse? I'm going to pop you back on this for a minute. See you in a minute. I should have thought of this before I started, but I'm out of USB ports on my laptop. The only one I have free is a Type-C. So I am going to have to plug in a USB hub. And when that comes up, I'm going to plug the USB stick into that. And now, hopefully, it should come up. There we go. What? Yes, okay, scan and fix. This always happens. Every time. No idea why. Like, there's no... It says there's a problem with it, but then it comes up and it scans it and it says, hey, there's no problem with it. And I don't know why. There we go. So we've got Windows Explorer up. The file that I printed was it this one? Yes. So a really cool trick, if you get a file that prints absolutely perfectly after you've tweaked the settings in Cura, it is entirely possible to recover those settings, even if you forget what they are. If we go into our profiles here for our different settings, these are the three that I created that I generally use. And there's a GitHub link. I don't think I put it in the description, but it's on a couple of my past streams if you want to check it out. What you can actually do, instead of just importing Cura profiles, is you can actually import G-code generated by Cura. So if I go to Gimbal PLA, you can see there are all the G-code files that I've rendered out and reprinted in PLA+. So this is the settings that I used to print out the other gear a couple of days ago. If I hit open, it's imported it as a new profile and kept all of those settings. So I am going to activate it. I'm going to rename it and we'll call it Spur Gear PLA Plus. Oh, actually, I better call it Snapmaker 2.0. So now all the settings I used to print that file a couple of days ago are now set up here on that Spur Gear PLA Plus. So yeah, if you ever get a file that prints really, really well, make sure to hold on to that G-code. Keep it safe. That way, one, if you ever need to print it again in the future, you've got a file that you know works really, really well. But two, if you get something that's similar, like going from 128 tooth gear to 160 tooth gear, you can just import the settings from that old G-code file straight into Cura as a new material profile. And then when we slice, get that out of the way, 6 hours and some minutes. That's probably wrong. The estimates for the Snapmaker aren't great, especially when you've got a lot of twists and turns like this and it's constantly speeding up and slowing down and never able to get to full speed. I'm not entirely sure what the acceleration settings are built into the Snapmaker. I need to have a play and try and figure that out and see if I can dial those into the Cura profile so these estimates are better. But there you can see it's sliced and we've got the regular grid infill, but we've got like 5 bottom layers, grid infill, 5 top layers, and then the little spindle bit prints in the middle. And we've got our chamfers. So what I'm actually going to do is save this out. I'm not going to start printing it yet, but I'm going to save it out so that it's done. So we'll call it that, but then we'll shift it into there. So here's a bunch of test files I made. Different spur gears. When I reprinted, let me see, when I reprinted, this was the first one that I printed. This one was actually my second print, and when I printed it, I wanted to try and get rid of a bit of the slop on this spindle in the bearing because it was quite loose. And the bearing was quite loose and a little bit wobbly. Because he'd done it at 9.5 centimeters, so I had to add a little bit of horizontal expansion. So there's a little, the cam leg hinge. It's the same sort of thing on the other side, but it just glues onto the arm. I've got one here somewhere. Find it. Nope, I don't know where it is. Ugh. Where? Well, it doesn't matter. It's basically this. It's basically this part of the disc, but without the rest of the gear. So it's just that, and it glues into there. So I made one of just the little nub and one of the whole thing at different horizontal expansion sizes. And then I just printed the little ones until I found the one that fit the whole just snugly. And then I reprinted that with the same horizontal expansion. But right, we'll call this PLA Plus Spur Gear M160. Save. So now that is on my little memory card, or it will be in a second, for the Snapmaker. close that and close them. And there are those. So I'm sure I'll have missed bits and glossed over bits, and people will have questions. So ask away, because I think what I'm going to do is have a couple of minutes to go get a coffee and go to the bathroom, and then we'll work on recreating that arm. And this should actually go fairly quickly. It's a fairly simple piece, but it involves some different techniques. But were you able to follow along with how to make the cog and draw sketches and other bits? Because I don't normally do tutorials like this. It's especially not on a live stream. So if there are questions, ask me now, and when we come to redesign this, I'll make sure to pay extra attention to them. If you're all good, say you're all good. Oh my god, I have had so many messages on Facebook. Say nope. 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 The cog. Oh, all right, cool, cool. This is the first time I've had to play with the cog thing. I remember seeing a tutorial about it on YouTube, probably at least a year ago, because it was something I wanted to do for another project, but I hadn't actually. I didn't know enough about Fusion 360 to do everything else that I needed, and so I ended up just buying off the shelf parts. But for this, it's like you can't just go on Amazon and buy 160 tooth gear. So I kind of had to force myself to sit down and play with it and figure out the other bits that I needed. You know, when I started playing with Fusion 360, I hadn't played with any other CAD software. So I'm not hailing this as the best. Certainly not the best for everybody. But the main advantage that this offers is, at least for me, is that as well as doing CAD, it also does CAM. So when it comes time to do CNC, if I model a part in Fusion 360, I can also have it generate the G code for the CNC. So it's, I don't know. I mean, it would be, it would make sense, like with 3D software. I mean, I can design, not easily, but I mean, I can design models in Blender for 3D printing and then just bring them into Cura for the actual slicing side of things. And that makes sense. So I'd be happy to do that as well with the CNC, but I just figured as Fusion 360 has both built in together, I thought I should probably try and force myself to at least learn enough about Fusion 360 to create what I want to create. But like for organic stuff, I use Blender. If I'm modifying an STL and not recreating it like I did here, I will probably also use Blender for that. While I'm talking, I'm going to hook this back up because when I go down for my break, I want to have the little gimbal dancing and doing its thing, so that you're not bored. But or at least, like, well, you can go for a break as well and make a coffee and have a pee and do whatever you need to do. But for anybody new that might pop on the stream, this will give them something to look at. But yeah, I mean, like the cam feature of Fusion 360 is that's what I'm really excited about. The CAD side, yeah, I mean, it's cool, you know. I mean, and it'll let me do stuff that I want to do, but it's not what excites me. I want to see it actually generate G code and have it tell the CNC machine or the CNC side of the Snapmaker what to do. But right. Awesome. Thank you, Christian. Yeah, I have got a big stack of foam to play with on the CNC first while I figure out Fusion 360. Because the last thing I want to do is like throw a big block of wood on there. And while I'm talking, I'm going to edit my message on here. But yeah, the last thing I want to do is throw a big block of wood onto the CNC and have the bit just dive right into it and snap off. I have got a pack of bits here. One thing I really want to do, and I know it's not the ideal tool for it, but I want to have a go at CNC milling, PCB milling. So I got a set of mills here. These are 0.8 to 3.1 millimeter with a 1/8 inch shank or 3.175 mil shank. And then I also got a whole bunch of 0.8 millimeter drill bits because I mean, even if I don't CNC mill the PCB itself, I would love to be able to have the CNC at least be able to drill the holes, because I'm totally happy doing the toner transfer method and etching PCBs in ferric chloride, because that's what I've been doing for 10 years. So I'm comfortable with that, I'm happy with that, totally okay with me. But drilling a couple of hundred holes, even with a drill press, is a major pain in the ass. So if I can load the whole thing into CNC, I'd be well happy. You know, because if I want to make like 20 identical boards and each one's got 50 holes in it, yeah, I'd be happy to. It wouldn't matter to me how long it took, as long as I wasn't the one doing it. But okay, let me line you up. See you out a bit. There we go. We'll get you lined up. Bring up Universal G-code sender. Reset you to 0. I need to connect. Reset to 0. Load up the file. And run. And I'll be right back. If you have any questions while I'm gone, oh shit, I just realized there's music on that bit, and you probably didn't hear a word I said, did you? Right, I'm gonna go get my coffee, grab a pee and whatever. If you have any questions, drop them in the chat, and I'll get to them when I get back and try and explain any bits that I missed or you thought I could go into a little bit more when we redesign the arm. All right, I'll see you in a minute. All right, the music's gone. Hey Daniel, how you doing? Oh, good. You can see the chat now. So, God, it is freezing outside. It is currently, what is it outside? Oh, it's exactly 0 degrees. I don't know if can you even see that on there? It's there you go, 0 degrees. You can see it at the top. Yeah, it's cold outside. Um, and it's nice coming back into a nice warm room, except that this fan is going nuts, so I'm unplugging that. So the fan's there for the stepper drivers, but it's not like a 3D printer where they're constantly going for, like 3 days. So I don't know if I actually need the fan, but okay, we'll unplug this. Oh no, Windows Explorer on my desktop has stopped working. Yeah, that was huge. When I figured that out, my mind was blown. Um, I made a perfect profile for one of my i3 clones for PETG, and then I went and upgraded to Cura 3.6, and I didn't notice the checkbox that said save everything, and I accidentally lost all my profiles, and I must have spent probably 3 months trying to create the perfect PETG profile again for that printer, and I couldn't do it. And then I somehow accidentally discovered that you could. I don't even remember how I found out now. It wasn't a tutorial. I think I just remember importing and just randomly seeing G code files coming up in the list, and I'm like, I wonder. Because I had seen some of the settings in the G code files when I loaded them up in a text editor, and then I'm like, ooh, I wonder if I've got anything I printed with my old profile. And tried to import it, and it worked. So yeah, any G-code files that print absolutely spot on, save them somewhere, back them up, have 2 or 3 copies, so that if you ever lose everything, at least you can recover your profiles from G-code works. I always keep G-code files that print well anyway, just in case I need to print another one. Thank you, Westwind. How are you doing? Or Northwest Wind. But right, we're going to do this arm. We're going to initially design it as is. We're going to put these 2 holes in. We're not going to bother with these because I don't get the point of them. Like I said, on the original listing on Thingiverse, let me bring it up. He has I want to go to desktop. So you can see on here, like, there's nothing on the front, there's nothing on the back, there's nothing that's actually, I mean, he's got these little cable clips, but they're just glued on, so there's nothing actually in these holes. And when you look at his video, we mute it to make sure there's no sound. He has a video, and when you watch it, like you can see the holes there and there, but as it all comes together, there's nothing attached to them, so I've no idea what they're for at all. So I'm just not going to bother putting them in. But right, so we'll close this because we saved this. We'll close that and we'll make a new one. We're going to do the same thing as we did before. We're going to go insert mesh, and the one we want, I believe, is cam leg. That's it. And we're gonna leave it where it is. And what we're gonna do first is we're gonna create a sketch and just draw an outline that's roughly the shape of this. So we'll create a sketch on that plane, and all I'm gonna do is I'm gonna select the line tool, and I'm just gonna zoom in to these corners to where they roughly match the grid. And just basically trace it all the way around on these corners. Because this the only thing that's important on this is that it's the right width. Everything else doesn't really matter as long as it clears like the existing components. And this is, I mean, it kind of feels like cheating just tracing around it, but if it works, you know, why not? And up here and across here, and I basically just zoom in until I see a grid line match up with the bit I want to click on. Oops, no, not that. Ah, did I mess that up? I did. So where is... Alright. So we'll make a new line from here to here. And this is one of the things I like about Fusion 360 as opposed to something like Blender. I mean, I like doing stuff in Blender. It's a cool piece of software, but, you know, this is why I like doing stuff in here. Because you can just, like, zoom in and make everything match the grid. And then we just close it off up there and finish the sketch. That's it. That's our sketch outlined for the whole arm. We bring up the bodies, you can see that it's right in the center. So with the whole thing selected, I'm just going to go E to extrude and we'll pull it out to, I think, is it 14 millimeters? Yeah, 14, but then we're going to go direction 2 sides. So now it will do the top and the bottom. Why is it? Oh, right, I've got a separate distance for the other side. So now we've got 14 millimeters on both sides. And now that essentially matches up with that. All we're going to do is round off these tops. So if we, oh no, I don't want to do that. I want to hide the mesh. Wait, no, I don't. Right. I want to select that one and that one. And here we're going to use fillet instead of chamfer because we want to round these over. And the fillet isn't exactly the same as this because this is equal. You can change it so that it's, you know, for a different height and width and whatever. But all I really want to do is I just want to make it look good compared to the circle in the center. It doesn't have to be perfectly round. I mean, it could just be like that. So this doesn't matter, but I want it to be just... So what were it was 14 millimeters extruded. Well, let's just go 14, and then that'll create a perfect arc around there. And then on this one, actually, if we double click on our extrude here, we can create another group, select those two, and this one I'm just going to go down a little bit because it just needs to see, like, if we go 14, it's another curve. I just want to round them off. I'm not bothered if they're not perfectly, you know, smoothed off like this one, because it really doesn't matter, because this gets bolted to the cog that we just designed. But that is basically our main arm done. Now we just need to figure out the hole placement. They're for lasers. Yeah, they could be. And oh, where is it? Somewhere. Ooh, is that it? No. Somewhere I've got a 2.5 watt laser module that I need to do something with. But I just got 15 meters of 2020 extrusion today, so I'm thinking I might build a custom larger laser engraver. But right, now we've got the sort of basic shape of the body done, we're going to create some more sketches to add these other details in. So these holes I'm not going to bother with. These two I am. So let me turn that off. And we'll create a sketch on here. And Again, I'm looking where these center marks line up. If I hide that, is that the center right up the middle? Yep. So if I, so it's right there. Right, so there's our center mark. We'll zoom out. Then these are 2.5 millimeters. And where's the other one? Oh, it's that side. Then we'll do the same here. $2.5 millimeters. So that's those. I don't know how deep these holes are. We change the opacity of this. Whoops. We change the opacity. We can see how far in those holes go. And then we bring that back. We need to change the opacity of that as well. Otherwise we can't see the other model behind it. So we'll sketches. Sketch 2, we'll select that. And that. Come on. Thank you. Extrude. And we'll push them back 10 millimeters. So that's those holes done. I'll set this back. Actually, no, I'll leave those there. Those are the only holes on the front. We've got 2 holes here on this side. So we'll make another sketch on there. And we'll set a hole here. And that's 2.5 millimeters as well. I like how he's designed this because everything pretty much aligns to the grid. We'll hide that and we'll select that. And where's the other one? Oh, it's there. And we'll select that. And then we'll bring up that mesh again. And these are probably 10 millimeters as well. Yep. So that's those done. These are for mounting this. Right, hold on. So these holes here are for mounting this horrible tripod plate. Let me actually, because I don't care about this. These 4 holes here are for mounting this tripod plate on. And there we go. I'll use my wow stick. This makes life so much easier. And if you're constantly, some of them are a bit stiff. If you're constantly messing around with stuff and screwing and unscrewing parts, or like building little kit printers, they make life so much easier. So much easier. Hold on. Apparently this camera's recording. I don't know why. Won't focus. There you go. That one. Yeah, I'm not going to be using this anyway, so it doesn't, keeping it on doesn't really matter. So those 4 holes are what that bolts into. So that's those. So we're not reproducing those. This is where we're going to be putting in these holes, which will, I mean, this is basically matches the dimensions of this, the width and the height. And then I'll align these holes roughly. I mean, I will use those holes just for alignment of this piece, but then that will have bolts going through it to attach wherever I've put it. Where have you gone? No, that's not it. That's not it. It's around here somewhere. Wherever the tripod plate is that I got. There's a couple of new people on the stream, so I wanted to show it. It's not in that box. Don't you hate when you put something down, then you go to look for it half an hour later, and you're like, oh, it's here, it's upside down, I just couldn't see it. So I got an actual Arca Swiss plate, and this is just another test block. So what I'll do is I'll use these to mark out, because the distance between those holes, remarkably, like the outside edge of this and the outside edge of this is basically exactly the same length as this block. So I'll measure in from the block centrally and measure out. I'll double check what my measurements were on this. I need an Allen key to remove these. Is it that one? Yeah. So I'll undo these. And I want to say that these were 70 millimeters apart on center. Yeah, the Wow sticks are awesome. A friend of mine got at me like 2 or 3 years ago for Christmas. And yeah, they're just fantastic. They're so handy. Yeah, so these are 1/4 screws. And they're countersunk to match the screws that I've got here. Let me zoom you in a bit. Move that over. So yeah, so these I think... Oh, actually, I can tell you exactly. The holes themselves are like 30-ish millimeters apart on center. I've got it exactly because I'll bring up my test piece. Yeah, they're like 30 millimeters apart on center. On center. And they're 1/4 holes. And then they have the countersink for the bolt head to go through. So what I'll do is I'll bring up the test piece that I made. And we'll pull the measurements off that, and then we'll just basically translate them to this and put the holes in where we need them, and then that's pretty much... I would be printing this that way. So these holes were printed that way and they fit perfectly. So we need to add in... You can't... Oh no, I haven't printed another one obviously because we're redesigning it. There's a bit... like I said, I need to find the other tub. I will be right back. I need to find this other tub so I can show you the part or what I'm going to say. Actually, no, I don't. I've got a computer right here with all the 3D files on it. So, if we look at the original arm, cam leg, we'll load that up. One of these, there is a hinge, one of these files. I don't know which one it is. Is it bearing? One of the bearing mounts? No, those are these bits on the outside that screw in and go in there. Base, bracket left, bracket right. I don't know what cam dovetail is. Oh, cam dovetail's this horrible thing. The tripod plate. Cam leg hinge. There we go. I'll bring this up as well. So right, so this is the way it prints. You can see there's a little recess in there. It's not that easy to see. If I slice this and go to preview. There you go, that makes it easier to see. So you can see there's a recess in there. And that is for this to go in. And this is what I was showing you before on the little memory card or the memory stick, where I had several different files at different horizontal expansions, so I could find the one that had the right fit for the bearing, which had the snuggest fit. Because the outside of this is a little bit smaller than the inside of this, so you can position it where you need it as you glue it down. But yeah, so now we're going to put this big hole in. So we'll go around to this side will turn right. So there's that model. We'll make a new sketch on this wall, turn that on, and we'll go to the center of here. Let me make that opaque so I can see it better. So I think the center is going to be like right around there. Yeah, that looks right, and it's 18.5 millimeters. Finish that sketch, select that, and then we'll adjust our opacity again to see how deep it needs to be. And it doesn't need to be very deep at all. I think it's only like a couple of millimeters, so we'll extrude that, and we'll go in 2 millimeters. And then that's that done. We'll set that back to 100%. So there we go. So that's your little cam hinge bit that goes in. So that's this bit done. We seem to have a couple of new people watching. So hello, new people. We're not doing these holes or these holes. We've done these. We are not doing these holes, but what we are going to do, I'm going to save this. And what was it? Cam leg. Oops. Cam leg. And I'm going to find my test piece. There it is. We'll close out. So this is my test piece, and you can see the sketch I made to test. So these holes are 6.8 millimeters in diameter. They're 15 millimeters from the center, and they're 14 millimeters from the edge because the whole thing is 28 millimeters. So the first thing I'm going to do is we're going to make a new sketch on this surface and bring up the original model and hide mine. Because what I want to do is I want to make something here. Well, actually, we can see the centers right there. If we go, whoops. Oh, what have I done? There we go. So there's a center. 15 millimeters left of that center. We've got a hole that's 6.8 millimeters. So if I go, is it 6.8 millimeters? Phew, yes. And then if I click this, if I press D, click this, and then click the center of this, we're looked out and got it in exactly the right spot. I'm going to make another one over here. 6.8 millimeters, and then I'm going to do the same thing again. I'm going to select that and hit D, and we'll go 15 millimeters. Finish the sketch. And then I'm going to select that and that, hide the original mesh, bring back my new one, hit E to extrude. We're going to change the extent from distance to object, and we're going to select the face underneath so the holes go all the way through. And then underneath the bottom here, I'm going to select that edge, and we're going to add a fillet. And I need to double check. I close that sketch. Here's our fillet, and it was 4 millimeters. Type equal distance 4 millimeters. That one. So if I go modify chamfer, go 4 millimeters. That's it. We're all set for these bolts that go through those holes and then mount onto this plate. Then that'll just attach to that. And I think that part was actually really quick to redesign. So I don't like that though. I know it shouldn't bother me, but it does. Was it that one? No. Oh, it might have. Yeah, it was that one. I'm going to remove that, and I'm going to bring this back here because I want to find a better way to do this. I want to round it out a bit more, and I'm not entirely sure how. Let me do that. We'll add another one, and I want to add that, and that to it. We'll play around with some of these settings because I've never really bothered with it. So this, what's chord length? I don't know what chord length does. That doesn't look any different to that. Oh, right. So constant is how far from the corner it goes, and chord length is the length of the actual curve. Oh, that's interesting. That's pretty cool. But other than that, corner type. Let me go back to constant then. Setback, what's that do? Absolute. Oh, well, that goes a bit funky when you try to. There's literally nothing. So I need to figure out another way because I want to round it off so that it's more like the original. So it's like a curved flat top, but I'm not entirely sure how. Oh crap! Damn it. There we go. You couldn't see what I was doing. I'm sorry. I want to try and make this top curved like that rather than how it was, where it was like this. But I don't know. I suppose it won't bother me once it's on the thing anyway. But I think that this is pretty much done. Yeah, ideally I will want to do this isn't the final redesign. This is kind of like sort of the next iteration of what I downloaded. So for right now, I'm just sticking with the way he's designed it because on the original gimbal, it's held up really, really well. Plus, I've used super glue to hold the screws in. So they're doing quite well. But I was just saying earlier that I did get a bag of 100 M3 heat inserts. So when I come to redesign this properly, I will be taking those into account and using those. But for right now, I'm just going to stick with the way he's done it. Because it is holding really, like surprisingly well, actually. Especially with the super glue in the screws. So that's what I'm going to stick to. But I think this part, this was it. This went a lot more quickly than I expected it to. Because we've got our holes there to attach the cog to. The 160 tooth gear, we've got our holes there for our tripod plate, we've got holes there for the induction sensor and the little indent there for the other hinge on the other side. And then we just got to save this out. So same again, it's just file, 3D print, choose that. We're not got that checked because we want to save an actual file. And we'll call this john-camleg.stl. And this one, let's see, let me close that. Close that. I'm gonna bring, where's my Snapmaker memory stick? I'm gonna bring my original Camleg settings in because they worked really quite well for PLA. And the only difference that I'm doing with PLA versus PLA Plus is changing the temperature. Every other setting is the same. So what I'm going to do is... Actually, I didn't even want to do that. I wanted to do the thing it won't let me do now because... Right, profiles. There we go. Import. This was what I wanted to do, Camleg. And then I'm going to rename that. Activate, rename, Snapmaker 2.0 Camleg PLA Plus. And then I will load. Where's the Camleg I just made? Where did I save that to? Oh. Can I save it in the parent directory? No, wherever. Oh, it's not even on the right drive. It's on the desktop in here. Files, John Camleg. And this again should hopefully be oriented correctly. So it looks like the guy who made the original did it in Fusion 360 because it seems to have automatically reoriented everything. Okay. Gonna go into the settings here. Snap maker to cam leg. 220. I need to change that on the other one as well. Update profile. But we'll yeah, I'm gonna need to re-export my other one. But we'll slice that. We'll save that out to PLA plus cam leg, and I'm going to need to reslice the 160 tooth gear because when it imported the other setting, it imported it from PLA, so I think the temperature's wrong. Oh, but it might not have done because it was the profile I used for the other cam. Let's see. We'll find out now. Oh no, I don't want preview, I want this. And I want the spur gear. Nope, it was set to 220, so we're good. So that's it. That's both of our files. Let me close everything down and close down Fusion 360. Oh, no, cancel. I want to save this. I did save it as an actual file, but now we've saved it as a... Okay, don't save that because we haven't changed that. But we've got our cam leg. Where was that? Did I save that in the right project? I did, there it is. Oh, and there's my test. Right, close. Right, I'll leave those loading up. The questions. If you have questions, now's the time to ask them. I don't know that I can answer them, but I will try. But there is our 160 tooth cog with the holes for mounting it to... Oh, those are on the wrong side, I think. No, they're not. No, they're not. Those are our holes for mounting it to the arm that we just made. So those holes there line up with those holes here. Let me close that. If I do that. So yeah, so these holes here line up with those holes there. Excuse me. And then these two holes are for wherever I'll put it again now. I have several of them, so if I lose it, it's not a massive deal, but that's for this end stop, which will sit on here and trigger when it taps that. And what I will probably do, because I have some little hex nuts up there, like the little risers that they use in PCs and stuff. I've got a packet of those, so I will be probably be raising it off here just a little bit because the little pins and whatnot stick out underneath. And then in the arm, it's basically exactly the same as the one that's already on the gimbal, except we've removed a couple of holes that there doesn't seem to be any use for. We've gotten rid of the mounting holes for this really crappy little plate. I mean, I'm sure it works wonderfully for the guy who designed it because he designed it specifically for whatever tripod he has, but all of mine are either Arca Swiss or Manfrotto. Most of my photography ones are Arca Swiss. Most of my video ones use hold on. This is a bit dusty because I haven't used it in a while, but most of my video ones, like my video cameras, use these big Manfrotto video plates, which is kind of big for this. But then, like most of my video rigs, look like this. So, you know, you're not going to mount this on top of that anyway. So I want to use Arca Swiss ones with this, and I don't know where any of my Arca Swiss plates are. I know I've got some somewhere. So So yeah, the origin when I originally printed the gears, it was one of the first times I'd done like a big print that almost filled the bed. So I did put a brim on it. Here there is one. If I tell it to slice, well, here there's a skirt, not a brim. So there is a skirt going around it. There shouldn't be one on here. There will be a skirt, but not a brim. If I tell this to slice. But yeah, the very first time I printed these gears for this, I did add a brim. Purely because I hadn't printed anything that big on the bed before, and I wanted to be sure that it had some assistance sticking while I was still figuring out the printer. But then I had a couple of prints where I forgot to put a brim where I otherwise might have put one, and they just stick beautifully. So when I reprinted the 128 tooth gear a couple of days ago, I didn't bother using a brim. I had a brim on this because all I did to reprint this was load the G-code file into a text editor and change the temperature from 200 to 220, and the original file had a brim, so this printed with one. The original one of these that I made that's currently on that gimbal had a brim, and it was a pain to take off, like an absolute pain to get in between each of the teeth. So when I reprinted it, I just thought, yeah, I'm not going to bother with a brim. So when I reprinted it a couple of days ago, there was no brim on this, and it stuck just perfectly. So I'm gonna print this 160 tooth one without a brim either. I will use a skirt though, just to make sure that the nozzle gets primed up nicely. But yeah, what you were saying about the hex things before, there's two ways you can do it. You can either cut slots and have embedded nuts, or you can use the heat inserts that I showed earlier. And Christian mentioned these actually before when I was talking about the holes to screw straight into. And I ordered these probably about 6 weeks ago on AliExpress, and they just showed up a couple of days ago. So I haven't had a chance to play with them yet. But once I figure them out and I'm happy with them, then yeah, I'll be designing or redesign. I'll probably end up redesigning the whole gimbal to something completely my own design rather than working based off somebody else's. But then that will have heat inserts or heated inserts to hold everything together. Yeah. But it's been a lot of fun playing with this, and I cannot wait to get like the rest of the parts printed in PLA Plus, get all the wiring together, because I got a bunch of the sheathing to tidy up the wires, and I want to get out and use this because I wish I'd had it over the weekend actually, or last weekend, and most of the last week, because we've had quite a bit of snow in Scotland, or at least in this part of Scotland, the last couple of weeks. And I went out on Thursday or Friday for a nice walk in the woods behind the house to go check out the snow and get photos of it, and it just looked stunning. It was absolutely gorgeous. So I wish I'd had this then, because this whole thing runs on 12 volts. So if I want to, hold on 1 second. I've got a whole bunch of 11.1 volt lithium ion batteries from my drone that I haven't flown for a couple of years because it died and my controller got stolen. But I've got like 8 or 10 of these batteries, so I can basically power this whole gimbal from one of these, including, you know, both the motors, the Arduino unit, the ESP32, and just power everything from this in the field. And that's my plan. I want to be able to use this out in the middle of nowhere. Yeah, so basically the way you use them, like you said, yeah, you basically you have a hole that's a little bit smaller than the size of the insert. And that's what I've got to test. I need to print a piece with a whole bunch of differently sized holes to try and figure out which one's the best to use with these. And then you just use your soldering iron. And fortunately, I was just looking before, the tip on the TS100 is the absolute perfect size for these little M3 heated inserts. I mean, it just, like, it couldn't fit any better if I'd planned it. It just fits perfectly inside there. So this heats up, it heats that, and then that gets pushed into the plastic. Oh, so that gets pushed into the plastic, and then you got to hope that when you pull your soldering iron away, it doesn't come away with it. But that's basically it. So you want your hole small enough so that this will go in and grab it, and then, but you can always, once it's in, like if you've got it on your soldering iron, you know, you can always just use a little Allen key or a pair of tweezers or something to hold it down while you pull the soldering iron off. So if it's, actually, let me grab a pair of tweezers. Ugh, dropping stuff everywhere. So yeah, so you know, if you've got it, like, where's the focus at? So if you've got it pushed into the plastic, you can always hold it with a pair of tweezers while you wiggle your soldering iron free, and it won't go flying off because it'll be stuck in plastic. But yeah, that's basically how you use them. At least that's the theory of it. Like I said, I only got these a few days ago, so I haven't tried it yet. So I need to print off some test pieces that have different sized holes in them. I could probably actually test it with, actually, yeah, I could probably test it with these. Although I think those will be a little bit small, but I think that might be the right size for it to give it a good test. Because that's designed to let that's designed to let an M3 screw pass right through, because it screws onto, let me zoom you out, because it screws onto that arm. So the screw just slots through here but screws into that. So actually, let's see, have I got a 24-volt power thing here somewhere? Yes, I do. Let's give it a try. Why not? Because I'm not going to be using this piece. So we'll do that. We'll pull one of these out. And we'll see how well it works. The way I used to do it was I'd literally, like, I'd put a hex nut in there. Or like I'd design a hex into the thing, put an actual M3 nut there, put in a screw from the other side, and then just heat up the nut and pull it in. But these are like sort of the proper way to do it, and I'm not entirely sure whether you're supposed to push them in with the smooth side at the top or the smooth side at the bottom. I think the smooth side at the bottom, and I probably should have done this when the soldering iron was cold, but we'll do, whoop. We'll do this. So we got tweezers, we're good, we're not going to burn our fingers. So we'll put that on the soldering iron, and my soldering iron is at 300, so it's like my standard soldering temperature. And if I push that into, I'm going to have to try and zoom this in. And alright, so we'll zoom this in, and I'll try and do this so that you can see without burning my fingers. So put that on there because we want the soldering iron to heat that up. And a pair of tweezers definitely seems to be helping. And then we'll hold that on and push the whole thing there. And it's melting into it slowly but surely. You can see it's melting into it. And then when it's in as much as it needs to be, use the tweezers to hold it down and pull the iron out. Oh crap! That would be a good idea, wouldn't it? Thank you. I guess now I'll have to do another one. But that... Right, let me grab a M3 screw. Oh, I've got one right here. And that's holding really, really well. I mean, I'm pulling and it's not coming at all. Right, I'll do another one just because I didn't have it full screen. If I waste a couple of these, it's not a problem. So we'll grab another one. So these holes, these 3.5mm holes, look like they're actually the perfect size. So, right, we'll do another one. We'll pop that on there. I need to have a better... Because I don't normally stream from the computer, I don't have the ideal setup for monitoring what's actually streaming out. But right, so that's heating up. And then we'll push you in there. And it is melting through. Can you see it melting through? I'll push that straight down. And just when it's at about the right level, put the tweezers on and pull the iron out. And that's it. It's that simple. They're both in. Like, they're proper well stuck in. I'll give that a second to cool down. But this one is like... That's proper in now. That is not coming out at all. Where? Oh, let me unplug that so it doesn't burn the house down. Where are my pliers? I put my iron down somewhere safe. Where are my pliers at? I don't know. Turn you off because you're blinking. You know, I found my pliers earlier and I keep losing them, and then I find them, and then when I need them, I've lost them again. Well, it doesn't matter. I can't find them, but like that is not coming out. That is holding extremely well. And that one too, it's like it's not budging at all. I'm really pleased with those. The only problem is that you can see the plastic is pushed out of the way. Has filled up the other side. I have got I've got a 3mm reamer. So usually what I do, now that's not going to work. Where is my knife? Yeah, I moved all my tools out of the way because my tools are normally just like around on my desk, like here, and I moved the piles of them to other places to get them out of the way for the stream. Oh, right. Turns out my knife absconded with the pliers. Now we can give this a proper pull test. So this was the first one, like first attempt ever at using heated inserts. And that's in all the way, and that is definitely not moving. Definitely not moving. But what I'm going to do, can I push this plastic out by just screwing it in? Yeah, I can. That makes life easier. So I can just push it into, or screw it in to push that plastic out of the way at the back. That's super handy. And I don't need these inserts in this piece, but now I know 3.5mm hole holds them just perfectly. I'm really pleased with that. Really pleased with that. I'm definitely going to have to start using heated inserts a lot more with my parts. Now that I have some and I know what size hole I need and everything works, definitely. Because they make life a million times easier and much more secure. So when I come to redesign the gimbal for myself from scratch, I will definitely be using heated inserts. Although, yeah, it is off at a slight odd angle. Just a slight angle. So it's catching on the plastic on that side. Let me see if I got the other one in any straighter. So I still think I might build like a little press just to help make sure they're aligned perfectly. But they were surprisingly easy to put in. That one looks a bit straighter. Oh, it's not so straight that it's running freely. Like I couldn't just turn it with my fingers until it gets to just the metal bit. So it is catching on plastic somewhere. Just on the one side. But yeah, that's... Yeah, pleased with those. Very pleased with those. I'm going to have to order some more now, so I've always got a big stock handy. I mean, I mostly ordered these just to play with and test and try out and basically do what I've just done. Just play around with them. And I don't know why I'm opening that, because there's nothing to put back in. But that was why I just ordered a bag of M3s to try out, because I've got thousands of M3 screws and I use M3 screws for a lot of the projects. And I thought, yeah, I'll play with them, see how well they do. And yeah, I'm pleased. So I'm going to order like 1,000 of them now. So I've got loads. But I think that's pretty much everything as far as designing these replacement parts go. They're both basically ready to print now. They're sliced, they're saved out. This is history to be replaced by this, which I know, I mean, this isn't a 3D printed part, but it doesn't really matter. Like, all as far as something like this goes, all that matters is results, you know. So like, the screws aren't 3D printed, the bearings aren't 3D printed, the motors aren't 3D printed, so this doesn't have to be. I'm happy. I mean, if you've got a tripod plate that fits this, by all means go for it. I would possibly modify this cam a little bit because it doesn't stick too terribly well to the sides. I mean, it gets stiffer as you get to the center, but it's definitely, it doesn't get tight enough that it actually locks. So I'd possibly make it a little bit wider in the center, if you did end up going with this plate. But I mean, overall, it's a really cool design for a gimbal. I mean, it's very different to like the usual gimbals I get. Like, on the shelf next to me, I've got the Zhiyun Crane 2, Crane 2S, Crane 3 Lab, Crane 3S, the Moser Aircross 2, the Moser Mini P. But they're all like handheld gimbals for walking around. They're not motion control gimbals like this one. Although there is some sort of limited motion control functionality with all of them. But yeah, this was what I wanted. And Fhuable actually does something like this called the Qing or Ching or King or something. It's Qing. And I saw one at NAB in Las Vegas last year. And it was awesome. And then suddenly it didn't get released for like well over a year. And then by the time it was out, I saw this and I'm like, well, I've got the Snapmaker 2 coming, so I might just wait and print my own, which is what I've now done. But yeah, I think that's pretty much it. Any more questions before I go? Tell me about your Christmas. Tell me about your New Year. Did you party on New Year's Eve? Did you break social distancing rules? What did you get up to? I had a nice quiet Christmas and a nice quiet New Year. I watched the fireworks out my window. I might have had one too many vodkas, if there is such a thing as one too many vodkas. You can all hear me, can't you? Or is it just like a really long lag on the stream? Cool. Yeah, well, that's nice. I mean, it's good when you get to spend it with your family, because a lot of people haven't this last year. Because like my sister and her family and my mum live miles away. And even if I wanted to visit them, doing so was an impossibility because we weren't allowed to travel outside of our area. But oh well. Yeah, it does. Eventually, though, I don't care. The world will go back to normal. I'm I'm not saying I'm enjoying everything that's going on right now, but I am enjoying being able to, you know, do stuff like this and play around with projects and experiment and try new things and, you know, build stuff. And yeah, this is loads of fun. It's I'm loving this, but I'm not loving why. But it is forcing me to start learning things and trying things and yeah. But I'm glad I finally got to have a go at building this gimbal. And I'm glad that I finally have a printer big enough to print all the parts for this gimbal. In theory, these should print on like an Ender 3 or a Prusa or even the cheap CTC i3 clones. You only need like a 220 by 220 bed for these. You could possibly get away with a 200 by 200. The problem is like those cheap printers with the small beds do not heat evenly at all. And I actually tried to print one of these gears out about a year ago on one of my i3s, and the corners were just peeling up. Yeah, so yeah, I'm dying to have a play with the CNC. I've got the original Snapmaker as well, and I'm thinking that might go on CNC duty very soon, just so I can play around with the cam features of Fusion 360 without risking my Snapmaker too. I mean, it'd bum me out if I killed the original Snapmaker as well, but I'd still have the Snapmaker too. Oh no! Oh no! Did you speak to the guys at Snapmaker? Are they sorting you out? I've been loving playing with the Snapmaker too this last few weeks because I mean, in between work, I've had nothing else really to do. It has been a lot of fun though, a lot of fun. I'm gonna pack some of this stuff up out of the way. Oh, I need to keep that out for those screws when I'm out. Well, actually, I don't need them right now, but I'll put them all in there so that I've got them handy. Uh, cable sheath. Pop your M3 screw. As you can see, I have got loads and loads and loads. I think that's it in that unit. And loads. And loads. And loads of M3 screws. I've got more, but I just can't be bothered getting them all out right now. So I've been, I don't know, they just seem to be the most useful screws for a lot of things. They're just the perfect size. And even the 2020 extrusion I've got. Anything, there's a whole, I'm going to be building a Core XY printer with them, but I'm going to be building a couple of other bits with them as well. And anything that isn't structural that needs to be attached to it, I just printed up a bunch of adapters or the T-nuts that take M3 nuts instead of the M5, because M5 screws are ridiculously expensive, and apparently they're difficult to ship because I ordered a few hundred of them from a supplier in the same country a couple of weeks ago, and they've still not arrived yet, and they haven't given me a shipping number or anything. Well, they're a legit company, but they're just really slow to ship, I guess. But I paid with PayPal, so if they're not here in a couple of weeks, then I'll just dispute and order somewhere else. Yeah, it shouldn't be possible to plug it in the wrong way around. I haven't tried the laser yet, but like every other plug, like there's only one hole it can go in, really. I mean, yes, your X, Y, and Z, you might plug into the wrong ones, but that's easy enough to figure out. But things like your 3D printer head, your I guess not the laser head, but like the 3D printer head, plugging in the power supply, like there's only one way things can go and only one socket that can go in. So that does seem a bit weird that it would even let you plug the laser in the wrong way. But apparently that there have been a couple slip out where the plugs haven't matched what they're supposed to. So, but so far touch wood, with mine, I've not had any problems at all yet. But I am dying to play with the CNC. I cannot wait. That's going to be a lot of fun. Oh, yeah, that's true. If you got it in an enclosure, it is going to be difficult. I don't have mine in one. Like inside, while I'm printing, I don't really need one because I'm not using ABS and I have no problems with PLA, PLA+. I don't have problems with PETG on my other printers. I haven't tried with the Snapmaker 2 yet, but I don't expect I'll have problems. The only thing I'd potentially need one for is the CNC and laser, but when it comes to doing the CNC and laser, I'll be moving it out into the garage anyway. The only reason it's inside for printing is because it's warmer in here than minus whatever it is outside right now. -1. So yeah, it's -1 outside now. It's weird. It feels nice and quiet and calm and relaxing, and it's great. And I want to go outside, but it's freezing. So I don't want to go outside. Yeah, yeah. The CNC is going to be fun when I take it outside. I really cannot wait. And I don't know what I'm gonna do when I start playing with the CNC yet. I know aluminium is possible to a certain degree. Like you have to be really careful with your feeds and speeds and possibly be very close by with the WD-40 as coolant. Because I seen one or two people use the Snapmaker 2 to mill aluminium on YouTube. It's something I want to try, but I'm not going straight there. Initially, I'm going to start with some nice soft foam so that when I start trying to figure it all out in Fusion 360, I don't accidentally plow straight into the material and snap the bits. I figure if I've got some foam on there and I'm working on cutting into the foam, no, it's not a good idea, but I want to try it anyway. It's definitely something I'm going to build up to. But yeah, not like what's his name? Nicodem Bartnick or whatever is Nicodem. He posted a video a week or two ago of his Snapmaker review, and he did it like with relative ease. There was some caveats. Again, like I said, you got to watch your feeds and speeds carefully. You know, and you're not going to be cutting like highly detailed things. You're not going to be doing like, you know, reliefs of like coin faces and stuff. But for like cutting out relatively thin plate, that would do me fine. You know, and just drilling a few holes in it, that would do me absolutely fine for my needs for aluminium right now. Because what I would like to do is use the Snapmaker 2 to cut out corner brackets. To add support for a stronger CNC that I want to build. So that's sort of my goal with it right now. Is use the tools that I have to make not necessarily better tools, but better for a particular purpose. So I right now I'm going to be printing the Core XY parts to build a Core XY printer, so that I can keep printing while the Snapmaker 2 is doing the CNC and laser stuff. That's why I haven't bothered with the CNC and laser stuff yet, because I've just got too much stuff to print that will only fit on the Snapmaker. So I have got a big pile of stuff. I got 15 meters of 2020 extrusion. 310 by 310 millimeter heated bed, 24 volt. So this will be a nice big Core XY, similar size to the A350 really. But I'm not sure how tall I'm going to make it yet. I might make it 500 millimeters tall. I've got the Snapmaker, the Snapmaker 2. I've got a couple of i3 clones, and I've got a robot arm. And the robot arm is fun, but it's a really bad printer. Like, it can do really tiny. It's possibly similar sized prints to the original Snapmaker, but there's no heated bed. Like, there's not a bed at all. I literally had to put glass down in front of the robot arm, cover it in tape, tell it to print super, super slowly. Let me see if I can bring it up on here. And I'll show you what the robot arm is that I have. I mean, I got this beginning of 2018, and I will never get rid of it because it's like I've wanted a robot arm since I was like 5. So I'll die with this thing. You know, just purely because I want one, but it's one of these. And it's fun. Like, they're designed primarily for education. And there's like little gripper things and whatnot, and they are cool, but like they're really, really bad 3D printers, but they're so much fun. They're loads and loads of fun, but yeah, they're terrible 3D printers. So yeah. And then the i3 clones I've got are basically basically a couple of these that I've heavily modified. The CTC i3 Pro B thing. So I've modified them a lot. They're much more structurally sound now because I've added reinforcement braces and other things. The first one I got it on eBay because I went with one of the cheap kits firstly because I wanted to understand the mechanics, electronics, and software side of 3D printers. I didn't just want to be able to make stuff. I wanted to know how the tool worked that was used to make stuff. Because it's basically like the same stuff that's inside 3D printers, or that makes 3D printers work. It's the same stuff that's in here. These are the same stepper motors. In here is essentially Gimbal, which is essentially Marlin without the 3D printing specific stuff. So it's the same software, it's the same electronics inside here. You know, it's the same sort of principles. It's even the same G code to move this as it is to move 3D printers. So that was why I initially got one of the cheap i3 kit printers, because I wanted to learn about the devices themselves and how they worked, because I knew I could apply it to things like this. But once I've managed to sort of understand how they work and the faults and what causes the faults, where the mechanical failures can happen and how to prevent them from happening, and good printer maintenance and all the rest of it, I started getting really, really nice prints out of it. And these two i3s have been like PETG workhorses for the last 2 years, and they've been absolutely fantastic. One of them I will probably keep around. The other one will be getting cannibalized for parts to make this Core XY printer that I want to build. But it's yeah, it's a lot of fun. I love doing this stuff. Oh yeah, so this gimbal as well. This is what I ultimately want to be able to control it with. I literally bought, I don't have a PlayStation. I bought a PlayStation 3 controller like 2 weeks ago purely to be able to figure out how to interface it with this, so that I can use this to move it, you know, left and right, and tilt the arm up and down to set all my settings. And I can say, okay, turn there, do that, there's your first bit. Turn there, do that, that's your second bit. Now rewind and play, and it'll just do it. That's my ultimate goal with this, is to figure out how to make it do that. That's what I really want to happen. But I'll also have an app, because like these have well, these ones have built-in Wi-Fi. This one has built-in Wi-Fi and Bluetooth, and this is like a dual core 1 point something. No, it's like 140 megahertz processor, dual core or something. Like 4 or 8 meg of storage internally. I think this has got 4 meg of storage internally. This is a single core. But this has built-in Wi-Fi, this has built-in Wi-Fi and Bluetooth. So depending on how I want to deal with it, I can write a phone app that communicates over Wi-Fi or over Bluetooth to this and to the camera for shooting things like time-lapse and stitched panoramics and other things, and just fully automate the whole process. And it's basically just set the thing down on a tripod in the middle of nowhere, set the start position, set the end position, and hit a button, and it'll just go and shoot all the images for me that I want. Yeah, I really think now that I've really gotten comfortable with the Snapmaker 2, I think my original Snapmaker is going to go CNC soon. My only issue is that the CNC head is in the box that's under a pile of like 20 other boxes, so that's the only reason I haven't done it already. But it's a pile I need to sift through soon anyway, so as soon as I get a chance, I'm going to be swapping out the heads. Definitely. I've got so much stuff I need to do, and part of this 2020 extrusion is going to be going towards building like organization, like a new monitor stand so that I've got room underneath it so I can shift stuff out of the way, because there's stuff I always need to have handy, and normally it takes up this half of the desk, and it'd be nice to be able to just shove stuff underneath my monitors out of the way and keep this part of the desk free for when I need to actually, build stuff or do a stream like this. Yeah. But right, I think that's probably enough for tonight. I'm gonna go get some food. And is there anything good on TV tonight? If not, I downloaded a movie to check out. What was it called? The Midnight Sky, the George Clooney movie about a dystopian future where apparently the Earth's dying or something. And yes, Octoprint. I've got to do the Cura video. I still have to do that. Then after that, it will be Octoprint, definitely. And then I'm gonna start playing with the CNC. The Snapmaker one is 125 by 125 by 125 print volume. For the CNC, I'm not entirely sure. It might be 100 by 100. But I'm okay with that. I want to start off fairly small. Right now see even with the printing, it's like a lot of the stuff that I print, it's it doesn't need a 330 by 350 by whatever the bed is on the Snapmaker 2. There's so much stuff that I print that I can fit on the original Snap, like these handles. Like you buy reamers that are supposed to go in drills or drill presses or whatever. I want a handle. I don't need a Snapmaker 2 for this. I can print this just fine on the original Snapmaker. I mean, I printed this on one of my i3 clones because I didn't have the original Snapmaker at the time, but I could print this on the original Snapmaker. Yeah, I'm not a fan of Zoom. I'm not a fan. It doesn't seem to want to work very well. Plus, like I use YouTube because I can use OBS easy, so I can I can swap between the desktop and the camera, or have the desktop with the camera, or the camera with the desktop, or I can play music. So I like using OBS for this kind of thing. And because I've got because of the way all my cameras are wired up and stuff, because right now I've got 2 cameras hooked up to the laptop. I've got this one and the one in the other room with the printer that I normally stream with, but that's turned off right now. So it just makes life a lot easier. It's a shame they don't have the Hangouts properly anymore. I think they still got a version of Hangouts, but yeah. But this has been fun. I might have to do this again. I don't know what I'll do next time. But I definitely need to practice more with Fusion 360, that's for sure. But I was really quite pleased with how quickly I managed to get through those pieces tonight. Yeah. All right. Yeah, I think that's it. I'm gonna go get some food and give my legs a bit of exercise. Thank you everybody who has joined the stream tonight, whether you chatted or not. It means a lot. And feel free to subscribe if you haven't already, because I will have more videos coming. Like I said, I've got the Cura one that I actually planning to do tonight after food. I'm not going to watch the movie. I'm going to record that and then hopefully edit it up and get that live tomorrow, because I just want to get that done now. I had a few setbacks last month, but now, new year, not a new me. It's the same old miserable shit I've always been. But I am going to make that video. And then after that, I need to get Octoprint set up because I want to start shooting time lapses of the printer, and I've got a tutorial I want to do on how to edit raw time lapse in DaVinci Resolve. So I need time lapse in order to be able to do that. So I need to get Octoprint set up so I can shoot the time lapse to do that video. Everything relies on everything else, but Cura will definitely be next, and hopefully my plan now is to have it edited tomorrow, live if possible tomorrow. But that's it. I'm gone. I'm getting some food. Thank you again, everybody, for coming, and I'll see you again.